Hi everyone, in today's video I'm going to review how to use implicit differentiation to find a derivative. So in examples 1 and 2, I'm going to ask you to use implicit differentiation to find dy dx, which is the derivative, in terms of x and y. So if you remember how we did this in class, what we do is we take the derivative of each piece. And when we have a y, we have to take the derivative with respect to y, so we say dy dx next to it. So the first thing that we're going to do is take the derivative like normal. So the derivative of 3y is nothing other than 3. So we're going to put 3 here. But because we took a derivative of y, we need to put dy dx next to it. And then we're taking the derivative of 3x squared. Take the 3, multiply it by 2. That gives me 6. So 6x minus. Now the derivative of negative 4y squared, we multiply the 4 and the 2 and drop the power down by 1. So negative 8y. But since we took a derivative of y, we need to put a dy dx next to it. Now, the goal is to get all terms that have dy dx on the same side and everything else on the other. So the first thing that we're going to do is add this 8xy over to the other side. Add this 8y dy dx. And you want to move it to the other side. So you have 3 dy dx plus 8 dy dx equals just this 6x that's left over. And now if you look on this left side, you have a dy dx which is in common, so we could take out a GCF of dy dx. And after you do the division of the dy dx, when I do this term divided by dy dx, I just get 3. When I do this term divided by dy dx, I just get 8. This should say 8y. I don't know why I dropped it. Sorry, that should say 8y. So we have 3 plus 8y. And then to get this last dy dx by itself, we're going to divide both sides by 3 plus 8y. These cancel. And our final answer for our derivative, dy dx, is 6x over 3 plus 8y. I just want to make one comment about the way that we write the answer. You could have chosen to, instead of move this to this side, you could have moved the 3 over here, and therefore your answer might be a little off. So just to explain that, you could have a negative of every answer. So you could have a negative 6x, a negative 3, and a negative 8y. This is also an equivalent answer. So as long as every single term is negated, it is the same thing as this answer right here. All right, let's try another example. Same set of directions. This time I want you to find dy dx, but now I'm giving you a little bit more complicated situation here because I have a little bit more terms. You should also notice that this first term is a product rule. There are 2 things here. We have a high and a low. So we can make this first one my high and my second one my low. So remember, for the product rule, the formula is low d high plus high d low. And the d low means take the derivative of low. So the product rule is low times the derivative of high plus high times the derivative of low. So when we do this term, that's what we're going to have to do first. So I'm going to do that here in red. So I'm going to start with low with the formula. So my low is y squared. D high means the derivative of negative x to the third, which is negative 3x squared. So it's low d high plus high, which is negative x to the third. And then d low is the derivative of y squared, which is 2y. But I took a derivative of y, so next to it I need to put dy dx. And then we're going to continue like normal. So what is the derivative of a constant? 5. You should be saying 0, so we don't even have to write that. And then the derivative of 3x squared is 6x. And the derivative of 2y is 2, but I took a derivative of y, so next to it I need a dy dx. So same kind of concept here. These dy dx terms need to be on the same side, and these two terms need to be on opposite sides. But before I do any of that, I think I'm going to simplify. I'm actually going to multiply these two terms together. So that would give me negative 3x squared y squared, or negative 3y squared x squared, whatever you prefer. Then I'm going to multiply these together. Positive times a negative is a negative, so negative 2x to the third y, or yx to the third, doesn't matter, dy dx, equals 6x plus 2 times dy dx. I like doing this step because it just makes things a little bit cleaner. And now I can go ahead and take this term and bring them to the same side, and these terms can go on the opposite sides. Now, this is really where, it would be better if you didn't write down every single step, but you actually just put little arrows, like I'm going to take this guy and I'm going to move it to this side by subtracting, and then I'm going to take this guy and bring it to this side by adding. It just gets a little messy, but if you feel like you need to write it, absolutely write it out. So if I follow my pattern, I'm going to leave this first, so this part's going to stay. So this is going to be negative 2x to the third y dy dx. And it's going to be joined with this term that I'm bringing to this side. So this is a positive 2, so I'm going to bring it to the other side by subtracting. So minus 2 dy dx. And this is already here and it's not moving, so this stays as 6x. And this term is now being brought back to this side by adding opposite sign. So plus 3x squared y squared. I just think it's a little cleaner this way, but again, feel free to do it however you'd like. All right, so now we're going to take these dy dx's, and that's my GCF. So I'm going to pull out the dy dx, followed by an open parenthesis. And when I divide this term by dy dx, I just get negative 2x to the third y. And when I divide these terms by dy dx, I just get negative 2. And this right side stays the same as 6x plus 3x squared y squared. And then the last and final step is to get dy dx by itself. I'm going to divide negative 2x to the third y minus 2. So my final answer for my derivative, dy dx, is 6x plus 3x squared y squared over negative 2x to the third y minus 2. And that is my final answer. All right, and just that same comment as before, when I want to write it in a different fashion, every single sign could be negative. So negative 6x, negative 3x squared y squared over negative 2x to the third y, positive, I don't know why I said negative, sorry. So positive 2x to the third y and a positive 2. That is an appropriate answer, which you could have gotten if you moved things in a different fashion rather than the way that I moved it up here. All right, good. Let's try one more example. So my last problem for here is to use implicit differentiation to find now the equations of the tangent and normal lines at a given point. So here's my given point, and here's my equation. So what I'd like you to actually do now is pause the video and do your implicit differentiation, and then hit resume when you're ready for the explanation of tangent and normal lines. All right, so here's my work for the implicit differentiation. So the first term, when I take the derivative of negative 5y, I get negative 5, but I took a derivative of y, so I need a dy dx. My second term, I have a product rule. Here is my high, and here is my low. So I'm going to do that now. So low is first, so y, so low, d high, the derivative of negative 2x is just negative 2. So that's low d high plus high, which is negative 2x. And the derivative of low is derivative of y is just 1. But I took a derivative of y, so I need a dy dx. And then we have the derivative of 3, or a constant, is 0, so I don't need to write that. And the derivative of 3x is just 3. So before I do the implicit differentiation and move stuff to the other side, I'm going to simplify what I can. So this is negative 5 times dy dx. This is negative 2y. This is negative 2x dy dx. And then equals 3. So really all I need to do is take this one singular term and move it to this side. So I'm going to add 2y to both sides. And what I'm left with over here is, is negative 5 times dy dx minus 2x dy dx and 3 plus 2y. So my GCF out of these two terms are dy dx. So I'm going to take that out, followed by an open parenthesis. So dy dx. And it looks like the negative 5 and the negative 2x would be what we are left with. So negative 5 minus 2x. And then we divide both sides by that negative 5 minus 2x. So we get dy dx is equal to 3 plus 2y over negative 5 minus 2x. So this is our derivative. And we have to understand that the derivative, by definition, is the slope of the tangent line. So this will give me the slope of the tangent line when I plug in this point, negative 1, 2. So I'm going to do that first. That's going to be my first step in towards getting the equations. So step 1 is find slope of tangent line. So my derivative, dy dx, I'm just going to rewrite it, is 3 plus 2y over negative 5 minus 2x, and I'm going to plug in x is negative 1 and y is 2. So 3 plus 2 times 2, negative 5 minus 2 times negative 1. I'm going to pause the video, plug that in, and get an answer. Hit resume when you're ready for the answer. All right, so I got negative 7 over 3. So that is my slope, dy dx, of my tangent line. So the next step, just to put it all together, we'll call this step 2. Use the formula y minus y1 equals mx minus x1. So I'll put t for tangent line, and I'll put n for normal line. So remember, this is x1, y1, this point right here. And my slope is what we just found of negative 7/3. So if I put it all together for my tangent line, it's y minus 2 equals negative 7/3 x plus 1, because we're minusing a negative 1, so it would be positive. And then my normal line is just a negative reciprocal slope. So this just becomes 3/7, and then x plus 1. Everything stays the same. So these are your equations of your normal and tangent lines. All right, just one comment about the way that you found your derivative. If you had moved items in a different fashion than I did, your answer for the derivative may be different. This may have been negative, negative, positive, positive, and that's okay. You should have still gotten the same derivative when you plugged it in. So just know that you can have those opposite answers for your derivative as well. All right, that's it for today. If you have any questions, please let us know.